Same direction, and these two rotates the opposite direction.
Oh.
What does it give you any ideas?
So if you move one, and then you move the other one, you move one, then you move another one to create like.
Doesn't move, stuck in here.
Yeah, let's say you already
Like a
have it.
sequence.
So I give you the hint. So these two are moving in the same direction, clockwise, for example, and these are counterclockwise. Whenever, let's forget about three motors. Whenever I move a drone, whenever the propellers is moved this side, right? What is the third law of the Newton, by the way?
For every
force,
there's an opposite
Right.
force.
So you have a force, right, which generates a motion. So there should be an opposite motion, which will create a moment. So if only one rotor moves here, it will spin. The drone will spin. This is the helicopter. If you see there is a main rotors and there is something at the back, what does the back does? It compensates the moment. Otherwise, the helicopter will just rotate around its own axis. So what we do, we have these two moving counterclockwise and these two moving clockwise. So they all cancel each other. So there is no moment. But if we start moving this pair a little bit slower, but this one faster, we will create the moment, and the drone will start spinning. So if you can put that logic on the computer, you can make a drone move around its own axis. So now we have full control. We can move forward, we can move back, left, right, and we can move it around its own axis, right? So we have a full degrees of freedom control for the drone.
Yeah.
Is it clear?
Yes.
And maybe a simple question, but any ideas how drones fly with propellers? Please?
It's just as we said. It's Newton's third law of motion. So it releases like air pressure, and
It's called lift, yeah?
Yeah, and so it hits the ground, and an opposite force, but with the equal strength,
So
pushes it back up.
you thinking it hits the ground, but what if I'm like 15 meters high?
The air itself.
Exactly. So the rotation of the propeller generates a force. It's called lift force, and then there is the opposite force basically that brings the drone in the air, or like something like that. Do you have any questions? Oh, by the way, I forgot to mention, we have like multiple 3D printers in the lab, and we use them very extensively. Why would anyone use 3D printers nowadays? What is the advantages of using 3D printers?
Less waste.
Less waste?
To make a prototype.
Yeah, that's a good one. Why?
To test your prototype to make sure if you have any faults.
Okay, that's a good one.
Cheaper.
Of course.
You don't need any robots or any humans to do the work. You just buy the one 3D printer and the materials, and you can always use it whenever you need it.
Okay, so you're talking about like a big automated manufacturing
efficiency,
machine, right? Yeah.
Easier and less effort.
Okay, count. Last one.
You can take it anywhere with you.
I mean portability.
Like a factory, you can take it.
So let's roll back few decades back, right? In order to manufacture for me a single piece, I have to design it on my computer. It's called computer-aided drawing, like CAD software. Then I send the model to the manufacturer, right? And then they manufacture that for me, and then they send me back the model. So it may take few weeks, few months, depending how far is the manufacturer, right? But nowadays, I can manufacture that piece with the 3D printer within an hour. And if I don't like this design, it doesn't fit my design, I will redesign on the PC, on the computer, and then send it to print, and I'll have a second iteration. So within a day, I can have 5 iterations, compared to like I have to wait a month for a single part to be manufactured, right? So it saves me time, it allows me to do like a rapid prototyping, and allows me to test ideas. And I think you mentioned all of these things, and that's great. And we have carbon fiber 3D printer nowadays. We have it in the lab because we want to print lightweight and strong materials. We have plastic, yes?
How is that different from a normal 3D printer?
The carbon fiber is very hard material, so if you have a normal nozzle, basically the brass, it will destroy your brass because carbon fiber is harder than, the carbon is harder than the brass. So you should have a special nozzle and special technology to incorporate the carbon fiber inside your design. Yeah, so it should be diamond or ruby nozzle where you extrude from, yeah. And we have plastic, we can print resin-based parts as well. So the flexibility is there. Yeah, and what, do you have any questions?
What code is that?
Here?
What language of code is that? Yeah.
So for quick prototyping, we're using Python. But if you want to build a embedded system like that flies all the time, like already like a pre-production level, it's a C++. So it's a Python and C++.
Yeah. So from what I know, Python is easier. Python is easier to use, but C++ has like more functions and is more effective. It seems.
So they both have the same functions, but as you say, Python is easier to use because it's easy to understand. It's like a same language as we understand, right?
Yeah.
But the C++ is faster because it's built for embedded hardware, so it runs faster on a low level, I would say something, yeah.
Oh, okay. Thank you.
But in terms of functions, they are same. So you guys want to take a picture inside as a group?
Yeah.
Yeah, please go inside.
to activate the drone?
No, no way.
Okay.
Yeah, you can go inside and maybe the mentors can take picture.
How do we get inside?
Yeah. By the way, this is flying arena. So when you fly outside, you have a GPS, right? So you can have a 3D position of the drone. But indoors, there is no GPS. So we have those motion capture system cameras that can track any robot, flying machines. And
Can you see it flying?
no, yeah, you're too many. So yes, I'm sorry, but there is no flying.
This is the robotics lab.
Sorry?
This is the robotics lab.
Yes, it is. The whole thing is a robotics lab.
Okay, thank you.
Yeah, like we have bigger drones, of course, like outdoors and many stuff.
You mean those drones?
Yes, yeah. This is a commercial one. This is the build ones we built. Like if you see the propellers, this is like a very big drones as well. So.
Okay, commercial ones.
This is the commercial ones. Yeah, absolutely.
Okay, great. Okay, thank you very much for the interview. Thank you.